Year 10 PPE March 2022. This is paper 2, the calculator paper. Inequalities. What's this describing? Well, x is greater than -1, but not including because of the open circle. We've got to show this on the number line, so put a circle at -3 and another one at 4. One of them is including and not the other. So the including one is the -3, so we shade that in. Okay, so that's the first one, and we join them with a straight line like that. Okay, next question. Highest common factor of 60 and 84. Quite easy this. Just take 60 and 84. You could probably do this without, but just to show the factor tree, we can have 30 and 2. So this is the prime factors. The 30 splits to 15 and 2, and the 15 goes to 5 and 3. Okay, do the same for the 84. We have 42 and 2. We also have 21 and 2, and then we have 7 and 3. Okay, pair them off. So a 2 and a 2 pair off, a 2 and that 2 pair off, and we have a 3 and a 3 that pair off, and they're the only pairs we can make. Normally we would put those on a Venn diagram, and we don't need to. We can see that they are 2 times 2 times 3, which is 12. That's the highest common factor of both of those numbers, 60 and 84. The lowest common multiple of these two, well, they're quite low numbers. You've got a calculator anyway, so just write the 24 times table. Okay, 24, 48, 72, 96, 120. You don't need to go any further because you can probably already see that 40, 80 and 120 is going to appear on here too. So the lowest common multiple is 120. Okay, is appearing on both of them. So you just need to make that clear in your answer there. Okay, so that's 4 marks there for those 2 parts. Next. Okay, so we've got some information here. This is a travel graph. This is the first part of the journey. We've got to work out Sam's speed. Well, he travels, or she travels 20 kilometers in 15 minutes, from 10 to 10:15. That's a quarter of an hour. So the distance, the speed rather, is the distance divided by the time taken, which is a quarter of an hour. Okay, so 20 divided by a quarter of an hour is 80 kilometers per hour. Okay, and that's it for the first part of the question. And then we go on to part B, which is asking us to, on this grid, to show the rest of the journey. Well, look, we've got 10 minutes of rest. So that's from here, that's 10:15 to 10:25. And then the final part of the journey, 20 minutes at 75 kilometers an hour. Okay, that's a third of an hour. So it's a third of 75. So it's a third of 75. Okay, which is going to be 25 kilometers covered. Okay, and it's going to do that in 20 minutes. So basically, I've just got to make this line go from where it is now at 20 kilometers. Another 25 will take us to 45, and another 20 minutes would take us to 10:45. So what I need to do is just put the line there, and I've got to go 20 minutes along, and 25 kilometers up from where I am, which would take me to there. Okay, and that's it. Next question. Okay, fill in the numbers. Use the table function on the calculator, it's quicker. So you put f of x equals this function here and put the values of x in. If you do it manually, be careful because you must put a minus sign round each negative number particularly. So it's -1 squared minus 2 lots of -1 plus 2, and that will give you this value here, and that comes to 5. Okay, if you put the 1 in, that will come to 1, the 2 in will come to 2, and the 4 in will give you 10. They're the 4 numbers that are missing. You have to then plot those points on your graph, so just plot them carefully. -2, 10 is up here, and then we come down to -1, 5, which is here. Then we come down to 0, 2, which is there, and then it's 1, 1, and then it's 2, 2, and then we go up to 3 and 5, and finally 4 and 10. If it's not symmetrical and smooth looking, then you've done something wrong. Now this is where I'm going to have a problem, because I've got to draw this using the pen and tablet, and it's really difficult, so it will be all over the place, but I'll do my best. I'll choose this color here. So it's quite a wide looking line, which might make it slightly easier for me to draw, but it's not going to look very good, so I'll do my best, but you will hopefully make yours look better. It must go through all the points and try and be a smooth curve. Okay, and well, surprisingly better than I thought it was going to be. Okay, well there's my attempt at that with a very fat line. What I'm going to do now is, that will get me the next 2 marks. What I'm going to do finally is use it to find estimates for this equation solutions. Well, look, on the left I've got x squared minus 2x plus 2, which is what I've just drawn. I now need to draw the line y equals 4 on the same grid. So the line y equals 4 is this line here. And I just look at where my red line crosses the curve and estimate those solutions. Well, let's look at this one here. That's about minus 0.75, and this one is about 2.75. So all I need to do is just write those down. So x equals 0.75, okay, and x equals, sorry, that should be minus 0.75, and also x equals 2.75. Okay, they're estimates based on what I've done on the graph, but use your lines that you've drawn on the graph. Okay, that's probably closer to 2.7 actually, but that's fine. Okay, so next question. Okay, we've got to work out the perimeter of this shape. There's 5 parts to it. We've got 3 of them shown. What are the other 2? Well, it's this length here, which I'm going to call x, and this short little piece here, which I'm going to call y. Okay, so I've got x is going to be equal to the square root of 8 squared plus 10 squared, using Pythagoras Theorem. Okay, so that's the length that I've called x, the hypotenuse of the triangle. Okay, so that there is basically that length here. Okay, and to get y, that's actually taking off this part here, you see, is 10. Okay, because this is the base of this triangle, up to here is 10. So this bit y is that answer. So y is the length I've got there, which is x minus 10. Okay, because that value of x is a little bit more than 10. And then I've just got to add the 5 things together. So the total length is 8, the total perimeter, 8 plus 8 plus 10, okay, plus the square root of that, which by the way is the square root of 164, okay, and that simplifies further to give me 2 root 41, okay, because it's root 4 times root 41. So 2 root 41, okay, and the last bit y is equal to 2 root 41 minus 10. Okay, now you don't have to put brackets around any of this, but I'm just doing that and that just to show clearly the 5 different parts, the 3 numbers given plus that plus that. Put that in the calculator and you get 41.6 millimeters to 3 significant figures. Okay, and that's the answer to that. And it says at the bottom, give your answer to 3 significant figures. Okay, this is simple trigonometry here. So all we have to do is take look at this triangle. We've got to find the length of BC, which I'm just going to call x. And I can see that x is opposite the angle 56 and 12 is adjacent to it. So that means that must be the tan of 56. So therefore x is equal to 12 times the tan of 56. And if you put that onto the calculator, that will come out as the tan of 56 times that, and it gives me 17.8 centimeters. Okay, 17.8 centimeters to 3 significant figures. Okay, and the next part of the question is asking me to do the angle x, to work out the angle x, and I could say that the adjacent over hypotenuse, okay, so 15 over 18 is the adjacent over hypotenuse, which is the cosine of the angle x. Okay, so x is now the angle, you see. Therefore, x is the inverse cosine, shift cos on the calculator, of the fraction 15 over 18, and that will come out to be 33.6 degrees to 3 significant figures. Okay, and that's 3SF. Okay, now question 7 is also here, so we'll go straight on to that. Now question 7 is about these 2 liquids, and we just need to remember this. I'll just put this up here. Density is mass divided by volume. Okay, you usually see that in a little triangle. Okay, same sort of thing we use for speed, distance and time. Okay, and there it is. So that's that, and then we separate it out like that. Okay, so density is mass divided by volume, and what we've got to do here is work out the density of liquid C. So we need the total mass of C, okay, which is made of we know its density and we know its volume. So this is liquid A is 1.8 is the density of liquid A multiplied by its volume, which is 80. That will give me the mass of liquid A. The mass of liquid B is going to be 1.2 times its volume, which is 40. That comes to 192 grams. Okay, that's the total mass. The total volume is just going to be 80 plus 40. Okay, so the density of liquid C is going to be liquid C. The density, okay, is going to be 192 divided by, I'll just put it here, the volume is 80 plus 40, equals 120. This is my working. So it's going to be 192 divided by 120, and that's 1.6 grams per centimetre cubed. That's the density of liquid C. It's exact, okay? You don't need to round that or anything because it's exactly as it comes out. Okay, next question, and here we go. So this one is about a cumulative frequency. Lots of information. There's only 1 mark for this, and it says write down one thing that's wrong with the cumulative frequency table here. Well, basically these are the cumulative frequencies. So the 13 is 5 plus 8. The 25 is 5 plus 8 plus 12. And basically the 25 means everything from the beginning up to 30. So these numbers are wrong. They should all be zeros. And that's what's wrong with it. So all you need to say is inequalities. Okay, that's the things in this column here. Inequalities. Okay, should begin with 0. If you put that, that's clear. Now, what we're doing is we're actually saying what should be in place, which is another way of saying what's wrong with it. So that's fine. You could give an example if you wanted to. You could put, for example, 20 less than t less than 30 should be, okay, and just put 0 less than t less than or equal to 30. So if you give an example, in fact, you could just do that alone and that would be enough. So there's more than enough there to get that mark. Okay, next. This is a box plot and we've got to find the interquartile range. Read the scale really carefully, okay? This number here is the lower quartile and this number here is the upper quartile. And if you're really careful about that, you can see that that's actually 50, okay? And this is 188. Write those two numbers down. Okay, because if you get the answer wrong, they'll be looking for those numbers, and that comes to 138. It's the difference between the two. Okay, Becky says 50% of the people waited for at least 2 hours. Is she correct? Well, you've got to answer the question first, yes or no. So the answer is yes, she is correct, because the median, okay, is 50%. Right, which is, well, the median is halfway through the data, so the median is 120 minutes, okay, which is equal to 2 hours. And that's the reason. That's the best reason to give, the most obvious one. Now, Becky looks at some information about Tuesday, that's about Monday, and she was asked to compare the distributions, and she wrote, people had to wait longer on Tuesday than Monday. Give one reason why Becky may be wrong. See, we don't actually know if she's right or not from that data, but one reason, one obvious reason, is that the median, okay, on Tuesday, the median on Tuesday is equal to 100, and that is less than the median on Monday, which is equal to 120. And that is definitely all the information that you would need to put to get that answer. Okay, next. 2 investments here. Louise puts X pounds in better investments for 3 years, and at the end of it, it's worth that. So let's do that first. and then see how much she put in other words, what this X was. So I start with this amount of money X, and because I'm investing at this rate for 3 years, I multiply X by 1.025 cubed. Okay, and that will give me the amount after 3 years, which they're telling me is 344,605. Okay, so from that, X must be equal to 344,605 divided by 1.025 cubed. Okay, you don't need the bracket round that really. And that comes to a nice round number of exactly 320,000. Okay, so we now know that Sadiq puts that amount of money in and invests that for 3 years using the county bank. So for that investment, we start with 320,000. Okay, we first of all times it by 2% increase, which is 1.02 squared, and then times that by the 3.5% increase in the 3rd year, which is that. And when we put that in, we get the value of the investment, which comes out to be 344. So 344. Okay, 580.48. Okay, finish, and it finishes exactly there at the 2nd decimal place. So that is how much he has at the end of that investment. Okay, and that's the answer. A straight line graph, okay, and we've got 2 points we're given, so from that we can get quite a lot of information. We've got to find the coordinates of this point R, and this is divided in the ratio 2 to 3. Okay, so this length here is 2, this length here is 3 in that ratio. Now what I'm going to do is draw 2 similar triangles, and you'll see the significance of this in a moment. So if I go from this point here to below R there, okay, like that, and then drop straight down to there. Okay, that triangle there and that one are similar, but this one is 1.5 times bigger than this one. Okay, so basically if this length along here is 6, okay, I'll just put these numbers in here, you can see that that length is 6, this length here must be 9. Okay, to keep that ratio, and this height here is 3 because it's going up from 0 to 3. This must be 4.5. Okay, so it's quite easy to see that the coordinates of R are well, it's 9 along and a total of 7.5 because this bit here is 3. Okay, so if I just finish that diagram off like that, then I've got a 3 and a 4.5 added together to give me 7.5 as the y coordinate. So I can see that the coordinates of R are 9 and 7.5. Okay, and then I can go on to part B, find an equation for the line perpendicular to L. Now this line here, line L, has a gradient of a half, because for every 2 I go along, I go up 1. So for 6 along, I go up 3. That's a gradient of a half. Now a line that's perpendicular to it will have a gradient of the negative reciprocal of that, which is -2. Okay, so I'm just going to put that line in there, and this gradient here is -2. Okay, so the gradient is -2. Okay, well, a straight line with a gradient of -2, that's at 90 degrees like that, crosses the y-axis at 3, has an equation y equals -2x plus 3. Okay, next question, number 12. We have 3 brackets here to expand, so we start usually by leaving the left-hand one alone. So I'm going to write here x minus 2, and next to it the multiplication of the other pair of brackets using FOIL, first outer inner last. So 3x times 2x, 6x squared. Okay, that's the first. The outer will be 9x, the inner will be plus 4x, and the last terms, 2 times 3 is 6. Okay, combine those two middle terms to give me x minus 2 multiplied with 6x squared plus 13x plus 6. This time we have to do 3 multiplications with the x and then another 3 with the minus 2, and then simplified afterwards. So we're going to have basically all of these times by x, which are going to be 6x cubed plus 13x squared plus 6x, and then the same 3 terms multiplied by minus 2 instead. So we're having minus 12x squared, okay, minus 26x, and minus 12. Okay, now we just simplify that. 2 pairs of those terms will combine. We will have 6x cubed. In x squared, we're going to have 13 and minus 12, which is plus 1x squared. We don't write the 1, we just write that. We've got plus 6x and minus 26x, which is minus 20x, and we've got our minus 12 at the end. And that's a fully simplified expansion. Okay, it doesn't matter what order you do the brackets in, but we tend to keep them in the right order, but do the last pair first and then finish with that one. Okay, and that's 3 marks for that question. And next. Question 13. We have standard form. This number here as an ordinary number, well, what we've got to do is move the decimal point effectively 5 places along to the right. So we're going to end up with 4, 5, and then a further 4 zeros. Okay, so it would be 450,000. Okay, and just check, count back from there, 1, 2, 3, 4, 5. You see, this one the other way around, we've got the number in as an ordinary number. We've got to write it in standard form, so the point has to go 3 places to get a number between 1 and 9.99, which is 7, and it's therefore 7 times 10 to the power of negative 3. Okay, now this one here is an addition. Now usually this sort of thing is on the non-calculator paper, but this is a calculator paper, so you can use it. And if you do, don't type in 10 times 10 to the power of 3, but use a button on the bottom row of the calculator, which is times 10 to the power of. That does it in one go. So for this one, you'd write 4.2, press that button, and then the number 3, for example. If you're going to do it conventionally, put brackets around each number. But another way, of course, is just to do it manually. 4.2 times 10 cubed is 4,200. Okay, and 5.3 times 10 squared is 530. Okay, so they go out of alignment, the digits, because of the different powers of 10. Just add them together, you've got a 0, a 3, a 7, and a 4. Okay, and you can see that that's 4.73 times 10 cubed. Okay, so the answer is 4.73 times 10 cubed. Okay, and that's it. Now, question 14, the first four terms of a Fibonacci sequence are A, 2A, 3A, and 5A. Now, be careful here because this is the first four terms, all right? But the question is asking about the sum of the first five terms. Okay, so you've got to show that you've got to find the value of A, given that that is 228. But you need the fifth term, you see, and you've only got four. And the fifth term would be, well, if we understand Fibonacci, it's going A plus 2A is 3A, 2A plus 3A is 5A, 3A plus 5A is 8A. So the next term is 8A. So what I've got is that A plus 2A plus 3A plus 5A plus 8A must equal 228. This would be my working out. All right, if you add all those together, you've got 3A, 6A, and 5 is 11, and 8 is 19. So that's 19A, all right? And if you divide 228 by 19, you get that A equals exactly 12. Okay, and that's it. So quite an easy question. And next question. Question 15. We have here a quarter circle and a triangle subtracted from it to leave us with the area of this segment here, which we've got to find. So we just got to do a simple calculation here. The area of the sector, that's the quarter circle, is a quarter of pi times the radius squared. So it's a quarter of pi times 8 squared. And from that, we've got to subtract a triangle with half base times height. So it's a half of 8 times 8. Okay. Well, that's easy enough to work out. So that's 64 divided by 4. That's 16 pi. And from that, we've got to subtract 32. Okay, you can put that straight on the calculator and it gives you 18.26. Well, you need it to 3 significant figures. So 18.3 centimeters squared to 3 significant figures. Okay, and that's it. Next question. Okay, this is a question really about similar triangles. Okay, we got to show that, well, we got to find the length of CB, which is the length along the bottom here. Okay, that's what we got to find, the total length of that. The first thing I would do is put information in that I've been given. So I'm told that AD is 9. I'm told that DE is 2. And I'm told that DB is 6. Okay. Now, the best way to approach this is to just carefully work out the scale factor between the small and the large. Now, you can see that if this is 6, the total length from B to A would be 15. Okay, so the small to large triangle has a linear scale factor of 2.5 because 2.5 times 6 is 15, which is the total length. Okay, so I'm just going to write that down here. I'm just going to say 6 times 2.5 will take me to 15. That's my scale factor there, you see. All right, and so I know I need to multiply DE by 2.5 to get this as 5. And it makes sense to show you're working out on the diagram really like this. Okay, and now I can use some more information to get the rest of this. In fact, I can get this line CB in one go because I've got a right angle triangle here with a hypotenuse of 15 and a vertical height here of 5, okay? So I can say quite simply that CB squared, okay, so that's the length CB, is equal to 15 squared, that's the total length of AB, the hypotenuse, 15 squared minus 5 squared, okay? Well, that's 225 minus 25, which is 200, okay? So CB is simply going to be the square root of 200, okay? Now, if you can use the calculator, of course, because that's provided. You can use that in this paper. But the root of 200 is 14.14 to 4 significant figures, but you need that to 2 decimal places. So 14.14, and it's in centimeters to 2 dp. Okay, and that's it. Next question. 20% of the people got a score high enough for them to qualify for the second round. We got to find what score 20% of the people got, the top 20% scores, okay? Or the top 20% of people, what they scored. Well, we need to basically find the top 20% of this area. So let's work out the areas or the frequencies represented by each block. This is 5 times 0.8, which is 4. This is 10 times 1.6, which is 16. This is 10 wide times 2.2, which represents 22. And this is 15 times 1.2, which is 18. Add those together and we get a total of 60. Okay, so that means there were 60 people in this competition, and those 60 people, okay, we need to find what 20% of that is. That's 60. So 20% of 60, okay, you can do that in your head, is 12. So we've got to find where the top 12 people are. Well, if there's 18 people in this last block, it's very easy to see that 12 is 2/3 of them. Okay, there's not really a lot more you can do here than just show this with a little bit of supporting working. So I'm just going to put a line in there, and I can see the answer is going to be 30. To the problem, because basically I've got here, I'll just show you what working out you could put. So this here is an area of 18, and I've got to basically find 12, which is the last 2/3. So I'm just going to show that 40 minus 25, so that's the length of this base, is 15, okay? And then I'm going to say 12/18 of 15, okay, which is 2/3 of 15 is 10, okay? And then I'm going to take the total number of people, 40, minus the 10 represented, the total score is 40, the highest score, minus the 10 will give me 30. Okay, it's almost easier just to see that from the drawings and diagram on there, but that's some supporting working as well. Next question, 18. Now this is an unusual sort of question because it actually is about solving a pair of simultaneous equations. Okay, and we've got to find the coordinates of the point C using this information. Now, the first thing to say is, as you'll see in a minute, the diagram is not drawn to scale. These rectangles are a lot more like squares than they appear to be in this diagram. But let's see how we get that. So I'm first of all going to look at the total height of the diagram and recognize that A is at 4 and B is at 20. So the vertical height of this diagram is actually 16. Okay, that's 20 minus 4. Okay, so I'm just going to write that on there, 16. And I'm just going to write here my working for that. 20 minus 4 is 16. Okay, and the other fact I'm going to note is that the distance between here, that's the point 34, and the x coordinate of B, which is 11, that distance is 8 because it's 3 taken away from 11. So that distance there is 8. Okay, and as you can see, that arrow that's supposed to be 8 is not half of the 16 on the diagram, so it's not drawn to scale. Okay, so just to be absolutely clear, what I'm saying is that if I extend this line down from here, okay, that distance there, I'll just make that into a dashed line and you'll see what I'm trying to say here. Okay, so that distance across there is from 3,4 to 1120 is 8 units long. Okay, so I can use that information now to work out what the length and width of these rectangles are, because they're all similar rectangles. Okay, so if I just call these lengths A and B, so that's going to be A, that's the length of a rectangle, and the height of the rectangle I'm going to call B. Okay, and I'm also going to show that I got my 8 from doing 11 take away 3 is 8. Okay, so what have I got going across? I've got an A, and I've got also another A minus a B. So I can say that 2 lots of A minus B must be 8. And going vertically, I've got 2 lots of A plus B. So 2A plus B is 16. Okay, now if I take those two equations and add them together, if I call them equation 1 and equation 2, add them together, 1 plus 2 will give me 4A equals 24. Okay, so therefore A equals 6, and I can substitute that into any of these to find what B is. So 2 6s are 12. Take away B is 8, so B must be 4. Okay, so what I'm saying is these rectangles are actually 6 by 4. Okay, in dimension. Now I've just got to simply recognize that. So to get the point C, I can just add those numbers onto the coordinates of the point A. So I've got 3 4. Okay, I'm going to do it like a column vector. So the position of that point is 3 4, and I'm going to add on to it 6 to the x and 4 to the y. Okay, and that gives me 9 8. Okay, and 9 8 is the position of the point C. So C has coordinates 9, 8. Okay, this is about volume, area, and linear scale factors and ratio. What I'm going to do here is we've got these 3 spheres, and I'm just going to make a little table which will explain what's going on. So sphere A, B, and C. Okay, and this is going to be the length, the area, and the volume. Okay, now if I just put the volume of A here in this column. If I just put some lines down to make it clear. Okay, so we have this table here like that. So if I just take sphere A, we have its volume, and we also have that for B. So let's put that in first. So the volume of A was 125, and the volume of B was 27. Okay, now I'm going to cube root that to give me the ratio of the lengths. Okay, so the cube root of 27 is 3, the cube root of 125 is 5. So basically the lengths or the radiuses or any lengths in those spheres A and B are in the ratio 5 to 3. And ratio C is double the lengths of B. So the radius of sphere B to the radius of sphere C is 1 to 2. So if that's 3, this must be 6. Okay. Now, we're interested in the ratio of the surface area of sphere A to the surface area of sphere C. So we don't need to know what the surface area is. We just need the ratio of areas, any areas in those spheres. Well, if this is 5 and this is 125, this is 5 squared, which is 25. Okay, this one is 3 squared, which is 9. This one is 6 squared, which is 36. Okay, so that's all I need. I don't need this number. It would be 216, but we don't need it. We just need these two because it's the ratio of the surface area of sphere A to the surface area of sphere C. So the answer is 25 to 36. Okay, and my working out is very clearly shown in that table next to it. Okay.